Hello and welcome to Excellent Link Academy. For today, we'll look at yet the second type of variation called the inverse variation. Last class, we dealt with the direct variation and we'll look at yet several examples under that. Let's look at yet second type of variation called the inverse variation. Put down please. When one quantity increases or decreases at a rate that it's inversely proportional to the change in other quantity, this is referred to as inverse quantity. So here's the concept. For inverse quantity, let's say I'm given y and x. Let's say y decreases, we expect that x should increase. Let's say y increases, we expect that x should decrease. That's like inverse variation. For direct variation, I said that for direct variation, the concept there is that as one quantity increases, the other two increases. But in this case here, as one quantity increases, the other decreases. That's the concept, please. So the other quantity decreases. All right, that's your direct variation. Let's do some illustration. Let's say I'm given that y varies inversely as what? As x. So when it comes to inverse, don't just put x like this. It's wrong. This is a direct variation. I'm talking about what? Inverse variation. So I said y varies inversely. So that becomes you have to put 1 first all over what? That thing x. I have it here. This is how you express inverse variation. That I'm saying that given that y varies inversely, for inversely you have to put 1 first. So varies inversely as what? As x. So don't just put x, you put 1 first all over x. This illustrates or this explains or this perhaps say explain the concept of inverse variation. So here's the thing. What we know is that for me I will have that y. If I want to change this symbol, because what? Equal to and a k. That's the concept. And a k. But mind you, I have 1 over x here. So I have 1 over x. So I have this. From here, I'll have that y is equal to k times 1 is k. All over, I have this x here. By the way, I can say that this is simply what? The equation connecting x and y. If I say 1, 2, let's make k subject from here. How? Invisible 1 here. K times 1 is of course k. Y times x is of course yx. Or perhaps xy. Alphabetically order xy. So this is how you explain or elaborate the concept of inverse variation. So having said this, so let's look at examples on inverse variation and let's see how it works. Example 1 says, let's do example 1. Let's do example 1. Let's do example 1. Example 1 says, A, letter capital A varies inversely as 2 over d, and A is equal to 6 when d is equal to 4. Find the equation connecting A and D, and hence find d when A is equal to 12 whole number 2 over 5. How do you solve this problem? Solution to this problem. Solution is that they ask us that A varies inversely as 2 over d. So I'm given A varies inversely. Inversely, you have to put 1 first up over that thing you are given there is what? 2 over d. So I have 2 over d. So I have this. So A is 6. I'm given that A is equal to 6 and d is equal to 4. So at this point now, with these two things, let's solve first before we start solving what you have to find. Now, first, we said from this one, I'll have that the what's it called, the plain noise is entering my video, so I have to stop so that it won't be colliding with each other, right? So from here, this becomes a, right? To change the symbol, what do? Introduce equal to and a constant k, right? So into what? I have 1 all over what there? 2 over d in this form. So I have this. By the way, this is a round bracket, round bracket. Since I have used round bracket inside, I have to use what? A square bracket outside. So I have to use a square bracket outside. So I have it this way. From here, k times 1 is of course k. So I have that a is equal to k times 1 is k all over what? 2 over d in this form. I have this. To break this down, I'll have that a is equal to, this is k. This symbol here signifies what? Division. I have what? 2 over d. If I still break this down, I'll have that a is equal to k. To change division to times, what's the concept? You what? Reciprocal. You invert. So d should come first. So I have d over what? Over 2. So from here, a now will be equal to k times d is what? Kd over 2, right? Mind you, don't forget that we want to make k subject. So to make k subject here, in this one here, 1 times kd is of course kd equal to a times 2 is what? 2a. I want to make k stand alone. I will divide by d. So divide by d. So I'll have what? Kd over d equal to what? 2a over d. This cancel this. What's now k? K is equal to what? 2a over d. But basically, I'm given a and d. So therefore, I can see that k is equal to 2 into what's a? A is 6 over what there? Over d. What's d? That's 4. From here, 2 times 6 is what? 12 over 4. So therefore, k is equal to what there? 3. So k is 3. So my k here is actually what? 3. So I've gotten k, right? As we usually do. You get k first. Alright, what's the question now saying there? It says that find the equation connecting a and d. I said that earlier. You can use this one as the equation connecting a and d. Right? So this is the equation connecting them. If I want to, and I can still use this one too as the equation connecting a and d. Right? But better still, let's use this. So from here, the equation connecting a and d, is given by what? A equal to, of course, k times 1 is k. So I have k all over what there? 2 over d. Right? So I have this. By the way, what's k? But I can leave this as my equation connecting them. But by the way, I know k as 3 now. Just put your 3 there. So, but k is 3. So, therefore, the equation connecting a and d is given as a equal to 3 over 2 over d. So, this is the equation connecting a and d together. So, I have this. Next up, it says find d when a is equal to 12 over 5. So find what? Find D when A is what? 12 whole number 2 over 5. It's easy, right? What do you do in this case here? All right, the task is that I'm asked to find D when A is this. It's easy. We say when it comes to finding all this stuff, go back to your equation connecting them. That's it. Go back to what? Equation connecting them. From here now, I have that A is equal to what? 3 over 2 over D. Right? I'm told to find D. I look for D. Right? When what? When A is 12. So let me simplify this. Let's try this. If I break this down, I should have A to be equal to 3 divided by what? 2 over D. From here, I'll have that A is equal to 3 times D come up first and then 2 goes down. So therefore, A now is equal to what? 3 times D is 3D over 2. But I'm going to find D. So I'll try to make the subject here. How? I have another over 1 is here. 3D times 1 is what? 3D is 3D equal to A times 2 is what? Is 2A. So I'm having 3D equal to 2A left. So I'll make D subject to find my D. Let's use that side. Alright, from there I can see 3D over 2A. I have 3D equal to what? 2A. And I'm asked to find D, right? So let's make this subject. So divide by 3. Divide by 3. This should cancel this. So I'll have D equal to what? 2A over 3. From here, they give us A value. What's A? A is what? 12 whole number 2 over 5. If I'm to express 12 whole number 2 over 5 in fraction form, I shall about 62 over 5. 62 over 5, right? Because 5 times 12, right? That should give about 60. 5 times 12 is 60. 60 plus 2 is 62 over 5. So convert this mixed fraction to what? To improper fraction. So I have this. So I have known that A is not 2 over 2, 62 over 2. So this is not equal to, this is D equal to 2 into what's A now? Instead of writing the mixed fraction, write the improper fraction. That's what? 62 over 5 as A all over 3. From here, D is equal to, multiply this with this here, I shall have 24.8, right, over this 3. From here, D is now equal to 8 whole number 4 over 15. 4 over 15. So this is my answer, right? So this is how we solve this particular question involving inverse variation. Look at how I took my time to explain step by step, and then you don't just complex things up. So this is how you solve this particular problem. Let's do yet one more example before we dive into joint variation. Welcome back. Let's look at yet example 2 under inverse variation. Example 2 under inverse variation. It says that P is inversely proportional to third root of Q. Question A now says find the constants of proportionality. That's, you find K, that's the meaning. Find the constant of proportionality if P is 8 and Q is 27. Question B says find the equation connecting P and Q. C says Find the value of Q when P is 3. Let's get this done. I'm given that P is inverse proportional. That's inverse. Put 1 first over proportional to what? The third root of Q. Mind you, the third root of Q is not 3 root Q. This is wrong. This is not 3. This is read 3 root Q. But if I have 3 this way and I have a square root this way, right? Is in that square root this way. Q this way. This is read the third root of Q. This one is what? 3 root Q. This is the third root of Q, please. Note the difference, please. So this is third root of Q, and I'm given that P from question A, P is 8 and Q is what? 27. Even before then, let's even proceed, please. I have this first. Question A says find a constant, Abby. So let's get this done, please. What is constant? In this case here, what we know is that I will have P is equal to K is a constant now into what? 1 all over there, the third root of what? Of Q. I have this. From here, K times 1 is K. So I'll have that P equal to what? K times 1 is what? Is K all over what? The third root of what? Sorry. The third root of what? Of Q. As I have it here, as you can see. So this is like the relationship between Q and P, or P and Q. This is the relationship between them. All right, I haven't said this. Question A now says, question A is that I want to find the constant quantity. So find K. So find K when what? When P is 8 and Q is what there? 27. It's easy. Go back to this man. So now we said P is equal to K over the third root of what? 27. Let's make K subject over 1. 1 times K is of course K equal to P times this is what? Third root of 27P. Right? Basically, although what's P? P is 8, so let's put 8 here instead. Or perhaps I can put P here, and here should be just Q, right? There should be just Q for now. Let's now put the values. So K is equal to third root of Q, third root of what's Q? 27, right? Multiply what's P? That's 8. So K now will be equal to the third root of 27 is 3, right? This is 3 times 8. So my constant K is equal to what? 24 as my answer. So this K is what? 24, right? K is 24, as you can see. So let's calculate. The third root of 27 will give you 3, right? So times 8. So my K is 24. That's your question A. Question B says the equation connecting P and Q. So B says perhaps. Question B says the equation connecting P and Q is given by what? By this, right? That's P is equal to K, that's K all over third root of q, the third root of q. I can leave it this way and still correct, but mind you, we know k already as 24. So p can be expressed as what? K is what? 27, sorry, 24 all over what there? The third root of q. So this is like your equation connecting p and q. Finally, it says find q when p is 3. So finally, question C says find q, right? When what? When p is 3. To find something when something is something, it's easy. Go back to your connection. That becomes p equal to what? 24 over the third of what? Of q. Right? Of q. By the way, I want to make q subject because I'm looking for q. I will now what? Multiply. So this times this and then this times this. This times will give what? The third root of qp equal to what? 24 times 1. This one. This will give the third root of qp equal to what? 24. I want to make p stand alone, divided by q. Divided by, I want to make q stand alone, divided by p. So I should have, let me just clean this part off. So I'll have 3 roots qp all over p equal to 24 all over p. So this should cancel this. I'll have the third root of q is equal to 24 all over p. Now listen up, I'm asked to find just only p, not the third root of p. So to eliminate this third root, I will cube both sides. Cube both sides. So I'll have the third root of q, all cube is equal to 24 over p all cube. This cube will cancel the cube root. I'll have that q is now equal to 24 over p or q. So from here, q is equal to 24 over what's p? P is 3, so I have 3 here. Or what there? All cube. 24 by 3 is of course 8, then all cube. Therefore, q will be equal to 8 cube is 512, I think so. So 8 cube is what? 512. This is my answer for q when p is 3. So this is how I solve problems under inverse variation, as you can see in front of you. All right, let's dive into the third type of variation called the joint variation.